far is to solve for a trig equation, right? So right now you should know, and I'm recording this so you can look back on the video if you want, you should know how to solve for an angle when given a trig ratio or given a point on an angle in standard position. So lots of words here. Now, does this, hopefully this whole big long title make sense to everyone? Does it make sense to everyone? If I give you, you should know how to solve for an angle when given a trig ratio or given a point on an angle in standard position. So for example, given a trig ratio, and this is what your hands-in assignment's about, okay? So for example, given that sine theta equals, let's say, 4 out of 11, and theta terminates in quadrant 2. Okay, solve for theta. Do you know what to do? Okay, what do you do? Well, I want to find theta, right? So what will theta equal? How do I solve? So I go shift sine, right? 4 divided by 11. That's really the big, this is what it all boils down to right now, okay? The converting from degrees to radians, that's just a useful skill that can come in handy to solve for arc lengths and if you get stuck on a trig equation. But really, the number one thing so far is you should be able to solve for theta. So I'm always just solving for theta r, right? My first step is always theta r. I don't know if this is going to end up being one of my answers, but that's how we start, right? Now, I didn't begins for this. Okay, so I will say, I just want you to solve from 0 to 360. I have to tell you that, right? If I don't tell you that, the number of answers are infinite, okay? So come up with the answer, pull your calculator out, make sure you're on degree mode, and I want you to solve for theta. And I'll say to 2 decimals. To 2 decimals. All your answers have to be to 2 decimals. Okay? So sine theta is equal to 4/11. I tell you theta terminates in quadrant 2, so it's a quadrant 2 angle, meaning in standard position, here's my initial arm, my terminal arm is over here. This is where theta is, right? Agreed? So what do you get for theta r? 21.32 degrees, right? So this is, that's not my answer, is it? That's not my theta. My theta's here. I solve for my reference angle, but we know that sine of all the 4 related angles has the same value, so that's why I'm able to solve for the reference angle, and then I figure out what the answer actually is. So it's going to be 180 take away, right? It's the difference between 180 and the angle in question, so that's going to be 158.67 degrees, right?
68 or 67?
Oh, you're right, thank you, 68. Thank you for the correction. Good, right? What if I said to you, now that's the big skill. A secondary skill that you should know is find the other 5 trig ratios. To be honest, that's not so big of a skill, a necessary skill as solving for the angles. This is the number 1 thing you should be doing. Find the other 5 trig ratios, okay? If you know sine is 4/11, find the other 5 trig ratios. Okay. It should be pretty quick to find the other trig ratios, right? Carl, what's the process? What do I have to do first to find my other trig ratios?
I did
Yeah. Yeah, because if you're given a ratio, you're given the lengths of 2 sides of a triangle, I guess, right? So if I'm given sine, like if I was given sine theta is 4/11, what information was I given?
Adjacent.
So use the triangle method? Okay. So then, if this is theta, you were given this and this, right? So you just have to find this. How many people just didn't think of the triangle and just used that ratio x squared plus y squared equals r squared? Because if you know that it's on the terminal arm of an angle in standard position, you know that we can use this ratio, x squared plus y squared is equal to r squared. Either way, you're doing the same math, you're just kind of approaching it from a different thought process, right? Either way, I have to find x, so x squared plus 4 squared equals 11 squared. So x is going to equal what? The square root of 121 minus 16? The square root of 105? Now, the nice thing about trig in grade 12 is you can just leave it like that. You don't have to bother simplifying, you can just leave it. But sometimes the back of the book simplifies, so you should be able to figure out if your answer matches the back of the book. Once I have this, I can do all my other trig ratios, right? because cos is equal to x over r, tan is equal to y over x, right? And I've got, and of course we knew sine. Sine was given to us. So the opposite, or the reciprocal of sine is cosecant. The reciprocal of cosecant is secant. And the reciprocal of tan is cotan. And all I have to do is flip, right? Okay, there's one thing though. I'm not quite finished yet, am I? Because it said this angle terminates in quadrant 2. So what do we know about quadrant 2? Only sine is positive for the primary, right? I guess sine and cosecant. So these guys are the only positives. So what you have to do is you have to put negative signs on everything else, right? That's the beauty of reference angles. The reference angles and related angles, their ratios will all be the same. The values will all be the same. The numerators and denominators will be the same. It's just the signs that change from quadrant to quadrant, right? Yeah.
Sine is adjacent to divide hypotenuse, right?
Sine is op over adjacent. Sorry, sine is op over hypotenuse. And this is adjacent.
Okay, what you're looking for is adjacent, right?
Yeah, we were looking for the x coordinate. Yeah. Okay, so that was a quick review. So that's given one ratio, come up with all the others. The second one that you should be able to do is, of course, given point P, which is -2, 9, which lies on the terminal arm of an angle in standard position. And let's try this. Determine the 3 primary trig ratios and determine theta, all possible thetas in the domain. I'm making this a little trickier, right? Okay, so here's your point. I want the 3 primary trig ratios. Give me the answer for theta if I tell you the domain is from -2 pi to +2 pi. What happens if you have a domain like this? What does that mean? Yeah, it's like kind of answering the question twice in a way, right? You're answering a positive rotation and then a negative rotation. How many answers for theta should you get? Normally it would be 4, but this time I actually gave you where is that point? What quadrant would that point be in?
Yeah, 2.
It would be 2 again, you know? You know what? Let me change the point, sorry. Let me make this a positive and this a negative. Just to make it something different. We already did a quadrant 2. Let's do this, okay? Let's say the point is 2, -9. What quadrant is that in? Okay. So this time you actually know where the angle is. So that means this angle must be like initial arm, terminal arm, right? Somewhere here. Positive rotation. Negative rotation, right? 0 to 2 pi, 0 to -2 pi. There, I helped you out a lot. So this time there's only 2 solutions. Because if you're given a point, you know exactly what quadrant the terminal arm's in.
We have to figure out both sides.
And I want the 3 primary trig ratios. Which are the 3 primary trig ratios? Sine, cos, and tan. Then we've got the 3 secondary ones, the reciprocals, the cosecant, secant, cotan, but I'm not asking for those this time. I'm just asking for the 3 primaries. Abdullah, you know what you're doing here?
Yeah.
Good. Indeed, it sounds like you know what you're doing. You done, Carl? No? 2, right? Because if you're given the point, you know it's in quadrant 4, right? It looks like everyone got, from walking around, people I saw anyway that were working on it, they got their trig ratios. So what did I have to do first before I could state my 3 primary trig ratios? Find R, right? Because we were, Ibby, do you mind closing the door? Yeah. Thanks. Because we were given X and Y, right, Dee?
Yeah.
We were given this is X, this is Y. What trig ratio could I state right away without even solving for anything? Tangent, right? I know that tangent is equal to Y over R, so tangent is equal to -9 over 2. Whoops, sorry. Okay, now I have to find R. So X squared plus Y squared equals R squared. We established that because any angle, any terminal arm of an angle in standard position, so if I have an angle in standard position, like this, and it could be anywhere, but in this case, this is the angle, right? Because it ends in quadrant 4. So this is a big angle greater than 270, right? It's a very large angle. It's not part of a triangle. But I could draw a triangle, and I could make this angle the angle of interest, and I call that theta r. And all I do is take whatever point I'm given and connect it to the x-axis, right? And then this gives me a side of the triangle, but it's also the radius of a circle. That gives me that relationship that I can use. X squared plus Y squared equals R squared. And I can figure out my, excuse me, the trig ratios associated with theta r, and those trig ratios will be an exact match to the related angle. That's the cool thing about related angles. The trig ratios are identical. The only thing that changes is the positive negative signs, right? So I have to use this knowledge in conjunction with my all students take calculus. And I just have to fix my signs up. But the cool thing is, the trig ratios of the reference angle match the trig ratios of the related angle. So we're able to use right angle trig even if we have this huge angle we're dealing with, right? So if I can, and I can either draw my triangle, like Carl, I think, kind of pictures the triangle. D might just use the x squared plus y squared ratio, but either way, it's a quick way to find that third side. So here I do 2 squared plus, that negative sign doesn't really matter, does it? Because it's going to disappear anyway when I square it. So I saw a lot of r equals root 85, which is perfect. Now I'm able to do my other ratios, right? And sine is equal to y over r, and cos is equal to x over r. Now, the way I just kind of use my point values, given the point values, they kind of match up and make your, if you use the values given, you're going to end up with the right ratios. But remember, in quadrant 4, only cos should be positive, and sure enough, these two guys are negative, so perfect. Okay, I have my 3 primary trig ratios. Now I have to solve for theta, but they said solve for theta, or I said solve for theta, positive and negative. So if I solve for theta in the positive rotation, once again, this is my reference angle, right? So there's lots of different ways I suppose you could solve for this angle measure. I mean, you could say it's 2 pi, take out the reference angle if you want to for quadrant 4, but most of the time what we've been doing is just using our x-axis as the reference point, right? So 1 full rotation would be 2 pi. 2 pi. So theta will equal 2 pi, subtract the reference angle, right? But first I have to figure out what the reference angle is. I can use any one of these ratios, right, to find the reference angle. Which ratio did you use? They'll all give you the same answer. Use tangent, because that's what was given to you, right? Okay, the only thing about that is we never use negative signs for reference angles, so it's going to be 9 divided by 2. And I said radians, so make sure you have your calculator in radian mode. So shift tan, 9 divide 2, and this is what I get. 1.352, I'm just going to do this, dot, 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 dot. That's indicating to you that I'm going to leave that calculator in my, or leave that number in my calculator. Okay, so now what I have to do is I have to take, to find my actually angle measure, it's going to be, in the positive rotation, it's going to be 2 pi minus my reference angle. So 2 pi, subtract my reference angle, and I have it stored, so I don't have to do any typing it again. 4.93, I didn't say decimals, right? 4.931 or 4.93 if you used, okay? So this is the positive rotation, meaning this is the answer for, 0 to 2 pi, right? Okay, now I have to answer negative rotation, negative 2 pi to 0, right? Okay, so how do I do that? That's this guy. So here, this is the negative rotation. Everything's kind of flipped for negative. I'm starting at 0, and I'm going in the negative direction, right? So it's going to be 0 minus my reference angle, right? So 0 subtract 1.352, or just negative 1.352. And if you don't need to do the math, if you can kind of figure these out in your head, then that's the best way, right? If you have a strategy that you've worked out on your own. Negative rotation, it's going to be theta equals 0 minus the reference angle. And there we go. We've got our 3 trig ratios, and we've got our 2 answers for theta. Did people find success in that? Were you successful? Abdullahi? Partly? Okay. All right, I'm going to stop there for a moment. I'm going to give you a little time to work, maybe till the break. I'm going to tell you what to work on.